Hi everyone, welcome back. Hope you're all still full of energy and excitement towards the end of the day. I didn't think I would be, but somehow all of these lovely talks are keeping me going. Next up, we have Emmanuele Bassi telling us about a year in the life of GTK. So, Emmanuele has been working on GTK and GNOME for over 15 years, both as a volunteer and on commercial products based on GNOME technologies like Maemo on Nokia hardware. He will be taking questions at the end, so please use the chat in point that way in Renulus, not the chat, the questions tab above the chat to ask your questions, and I will pass them on to Emmanuele at the end. So thank you very much. All over to you.
Hi, and thank you. And thanks everyone for joining me in this presentation. And also thanks to LCA for giving me the chance to talk about GTK in this conference. So we're going to talk a little bit about a year in the life of the GTK project, since the GTK project has been doing a major release for the first time in nearly 10 years. So stuff has changed in the year before that, and in this year is changing again. There's lots of stuff to cover. So let's start. So I am part of the GTK development team, and I've been working on GTK and GNOME for about 15 years now. I'm mostly involved in a core application development platform, so core libraries, but I also work with the developer documentation, the documentation team. I maintain the odd application, and I collaborate with other GNOME maintainers in the release team. My contributions have been part of both my literal job for years, but I also worked on GNOME and GTK on my spare time. So I'm usually able to appreciate the use of GTK and GNOME technologies as a downstream developer as well as a volunteer. GTK is a very old project these days. It's nearly 25 years old. It's been in continuous development since roughly 1995, 1996. When it was written as part of the GNU image manipulation program to replace Motif, which was the toolkit used at the very beginning. Over the past 25 years, GTK has seen 3 major version bumps, from GTK 1 to 2, from 2 to 3, and now from 3 to 4, and has been used and deployed to millions of devices all around the world. The last major release of GTK, GTK 4, is probably the biggest leap in terms of the toolkit internal design since the 2.0 days. And it was a change driven both by the evolution of windowing systems on Linux and by the challenges and the realities of maintaining a volunteer-driven free software toolkit with no central authority and very minimal corporate backing. So today I'm going to talk to you a little bit about the changes that led to GTK 4.0 in 2020 and what happened to the project and around it in the year since then. In 2016, the main topic of discussion about GTK was whether we could improve the rendering pipeline for GTK 3, which was the major version at the time, without breaking the API contract. The fact of the matter, though, was that we had been changing the internals of the toolkit a lot more than we did back in 2006 when we introduced Cairo in the rendering pipeline, and we moved away from the internal drawing API that mimicked and wrapped xlib. We were also looking at the transition period in which we'd say goodbye to X11 and hello to Wayland. And on the hardware side of things, we were seeing the adoption of a high DPI density displays on both laptops and desktops, as well as dedicated graphical hardware with 3D acceleration. During the GTK 3 stable cycle, we did change a lot of how the rendering pipeline worked to allow proper transparency between widgets, for instance, or implementing things like CSS borders and shadows that extended outside the widgets area and blended with the background. These changes required little to no updates in idiomatic code, which is good in general. But there was a lot of non-idiomatic code in applications that were hastily ported from GTK2 to GTK3 back when we released GNOME 3.0. This is a time when we did not make ourselves any friends with application developers that consumed the platform, and especially the ones that were consuming the platforms 3 years at a time by updating their development machines using long-term releases from distributions like Ubuntu. Our main problem was effectively Cairo. Cairo still is a high-quality vector-based 2D rendering API. While it introduced this high-quality rendering to graphical user interfaces, it was limited by its design, which reflected the era in which it was developed, so the early 2000s. Thanks to Cairo, we were able to move GTK to a CSS-based drawing state, just like web rendering engines. Like those web rendering engines soon discovered, it is effectively easier to take whatever state Cairo has, blow it away, and replace it entirely with a state of a CSS machinery that is held client-side in the toolkit. And this is especially true if you're rendering something that looks like a lot like a GUI as opposed to a vector image. Another problem at the core of Cairo was its reliance on fast readback pipelines between the CPU and the system memory, which is something that just does not exist in modern systems using a GPU. Finally, the maintenance status of the project had been in question ever since Intel poached the 2 people responsible for maintaining the library, one after the other, first Kyle Worth and then Chris Wilson. In the end, Cairo is an API that makes sense as an internal detail of the toolkit. Sadly, we exposed it as part of our API to application and library developers, and that made it necessary to write wrappers around it to represent a full set of rendering operations in order to hide the fact that the Cairo API didn't actually work the way we wanted. But at that point, though, why would you be using Cairo at all when Cairo didn't give you access to the most efficient graphical hardware on your system? Well, because sadly, the actual API that lets you access the hardware is OpenGL, which has been known to be a disaster zone for years, especially in Linux. Luckily, the introduction of mainstream X11 compositors using OpenGL, like Compiz in the mid-2000s and GNOME Shell in 2011, had the effect of improving the GL driver support, which in turn pushed more people to make use of GL for applications and games, and that it was coupled with improvements in the GL standard API, which deprecated at first and then jettisoned the old craft from the 90s, and basically pushed for using the GPU as a programmable resource instead of a completely opaque state machine. Implementing a GL-based CSS state renderer is much more tractable than implementing a fully generic vector API, and you can get a lot of mileage out of small shaders to do things like shadows, borders. This was demonstrated by projects like Mozilla Servo's WebRender, which acted as an inspiration for the GTK rendering pipeline. For instance, once you have a full tree of rendering operations, you can decide what changed from a previous frame, what didn't, and what to remove from the graph of operations since it won't ever be visible. At that point, you can re-render everything and do it faster than just caching intermediate states and then figuring out how to expire that cache. suddenly, by doing this, the rendering step of each frame is not the bottleneck anymore, and that gives you much more time to do layout at 60 FPS or whatever frame per second is the screen refresh rate, and also gives more time to application logic to do its own thing. Speaking of pushing 60 FPS, the task of doing so becomes really hard when you're dealing with large resolutions. Your CPU back in the day of the early 2000s, late 90s even, your CPU could deal with pushing 800 by 600 pixels or even 1024 by 768 per frame. But once you get to 1080p, 2K, 4K, 8K, or even multiple displays with very large resolutions, then you definitely need something more powerful than your CPU. And IDPI displays also require changing the nature of pixels from something that is physical, so it's an actual like point of light on your screen, to a logical unit. So you don't accidentally turn your desktop into the most challenging level of Minesweeper ever. And you'll need a magnifying glass to hit like ridiculously small buttons or to read very, very small text. This requires changing how you load image assets in your application, how you size windowing system surfaces, and how you align every UI element to the pixel grid, especially text. Otherwise, you get a blurry mess. Alongside the changes in the lower layers of the stack that impact directly the hardware, starting from the early 2010s, the clock began ticking for the old display server technology available on Linux, which is X11. Over the years, toolkits have moved away from submitting rendering commands to a server, and instead they started to send complete frames generated client-side. The X server usually stood in the way of making applications reliably present windows to the users for years. Even though we introduced, well, not me personally, but the X11 developers introduced extensions like the composite extension. Wayland, as a display server technology, promised to make every frame a painting with no interference by the display server. Sadly, GTK 3, just like GTK 2, was still very much designed on top of Xlib, which meant that every one of its backends was re-implementing the same Xlib design on other windowing system. And GTK exposed a lot of ostensibly independent API that only ever made sense or even worked when using X11. In terms of portability, as I was saying, GTK basically re-implemented Xlib on every single platform since the GTK 2.0 release in 2001. The ability to run a GTK application on different platforms and different environments was never meant to be used as ways to do like cross-platform, write once, run anywhere development. It was a way to port GTK applications from Linux and other Unix-like systems to Windows and macOS. And as I was saying, this amounted to re-implementing X11 everywhere. While this minimized the changes to application code, because after all, everything looked like X, it made everything more complicated to maintain and to fix and to test inside the toolkit. Every new functionality would need to be abstracted in ways that didn't always make sense, or they would be just left unimplemented. Plus, very, very few people could understand how the backends actually worked. A simpler windowing system protocol like Wayland would fit in a lot better within these constraints. So we come to 2016, and the internal changes that happened during the GTK 3 cycle basically just were not really for free anymore. Of course, most people only remember the theming issues at the time, themes which were never under any stability guarantee. The issues were mostly the result of downstream distributions of themes as packages without any additional QA process that would tie them to release of the toolkit they were ostensibly targeting. So people got broken desktops because they were using a theme that was not tested with the version of GTK they was, in theory, using. The main impact for application developers were not themes, were the changes in the drawing API, especially for applications ported in the early days of GTK 3. To avoid that happening again, just before of the GTK 4 development process, we decided to lay down some fundamental guarantees for application developers. First and foremost, that once the 4.0 release was done, the toolkit would be feature frozen. New API and new features could be added, of course, but existing functionality would never change, including the CSS selectors. So it's a little bit more strong than an API compatibility. Additionally, the new development cycle will contain a roadmap for future major API work, as well as the support window for existing stable releases to shorten the development cycle while providing a reliable schedule. So, feature freeze once stable, just adding small widgets, freeze the theme, shorter API cycles, and 2 supported API versions for a window of 2 supported API versions. So this is kind of a graph of our policy. You can see that we have the GTK 3 branch that goes on. We had to release GTK 3.24 to ease off the porting window, but basically from 3.24 we jumped to the 3.90 development process, release 4, and then from 4 we're going to start the 4.90 development cycle in probably 3 years time. But as soon as GTK 5 is going to be released, GTK 3 is going to be end of life, and the only 2 supported stable release versions will be GTK 4 and GTK 5. And then when GTK 6 is released, GTK 4 will be end of life. So it's much more explicit instead of just being random, whatever we want. So in terms of GTK internal and API design, the major version number 3 was still heavily influenced by the model of a deep object-oriented forest of types. This design encouraged developers to inherit from existing complex widgets, which had the side effect of locking some internal state to avoid breaking expectations. For GTK 4 instead, the design mantra has been to favor composition and delegation instead of inheritance. We made it easier to create your own custom composite widgets without exposing their internals. You can do that with object orientation and use XML to describe your UI and bind it to the class structure automatically, so you don't have to deal with the fiddly bits of loading XML yourself and then assigning pointers and stuff like that. There are a bunch of macros and a bunch of API that will deal with that for you. Another thing that we looked at a little bit later than we wanted, but it was hard to find resources and funding for that, sadly, was accessibility. Like Prometheus gifting humans with fire, the SAN accessibility team gifted the free and open source software world with ATSPY back in 2001. And Alongside it is by GTK acquired all accessibility API, first as an out-of-tree model because of dependencies. The legacy of that gift made things much more complicated over the following 20 years. The original design was heavily based on Corba, which is many things, but a nimble IPC mechanism isn't one of them. Additionally, the accessibility stack was heavily tied to X11, with application broadcasting the whole internal state and allowing other applications to take them over on unsecured sockets. And unprivileged assistive technologies were able to get and inject windowing system events across the whole desktop. This design also required layering the API across multiple components. You had the toolkit, which provided an implementation. Then you had the set of abstract types as a separate library, since they could be theoretically implemented by multiple toolkits and libraries, except it never happened. It never actually happened. And on the other side, you had the actual low-level library that sat at both ends of the IPC wire. On top of that, there was Sun scaling down the accessibility team, Oracle acquiring Sun and basically killing the entire thing, and the pool of people working on making the Linux desktop accessible to people with disabilities, it got smaller and smaller the more time passed. In the meantime, web browsers are where the action is these days, which meant having a whole new accessibility specification to follow, the W3C ARIA specification. So for GTK4, we decided to follow that instead of to eliminate all the layers and just speak the AT-SPI protocol directly and implement from an API perspective the W3C specification for accessibility. So what's new in GTK4? We have a new deferred mode rendering infrastructure instead of being an immediate mode with Cairo. So you don't draw directly, you submit rendering commands, and then GTK will take them and structure them in ways that make more sense. We use OpenGL by default and Cairo as a fallback. We use Wayland by default, even the design of the API is based on Wayland. We have much more simpler backends. So they are easy to test, fix, and maintain. We have a reliable release policy and a stable feature set for every single new major release of GTK. We use delegation instead of inheritance, making the API more reliable. And we have a new accessibility API. Of course, we also have to document all this stuff. GTK started off in 1997 with handwritten tech info pages for the API reference. And then the project was migrated to a custom documentation generator that would take comments from the source code and turn them into docbook XML first, and then that turned into HTML. The tool was called GTK Doc, and it served the GNOME project as a whole well enough to be reused for all other libraries. Sadly, GTK Doc was written in Perl, and its maintenance cost kind of followed the curve of every other Perl project. And at some point, since Perl fell from grace, it got progressively less maintained. There was a last-ditch attempt to port GTK Doc to Python, as well as trying to reduce the docbook's performance bottleneck. But basically, building the API reference for GTK took as much as building the actual toolkit. So 500,000 lines of C, plus examples, plus demos on our CI pipeline take about 6 to 7 minutes. And generating documentation for that took the the exact same amount of time. It wasn't tenable. In the meantime, though, since 2010-ish, every GNOME library started providing a machine-readable description of its C ABI, as well as the documentation for that ABI, in form of introspection data generated at build time. The typical consumer of this data are language bindings. They can use it both at runtime as a memory mappable binary blob, and they can also use an XML description for code generation. The XML description contains the documentation associated to every public type and symbols, and it's possible to use it to generate an API reference much more efficiently. It also has another advantage of using the introspection data. The generated API will match as much as possible the actual API that will be used by the language bindings. So you'll get something that is a lot easier to map between programming languages. So I wrote this tool called GI-DocGen, which takes the introspection documentation and the introspection data and generates the documentation and creates an HTML website. It's really fast. It takes about a minute to build the entire thing. And we publish it as part of our CI pipeline alongside the reference for other libraries. So GTK, GIO, Pango for text, GTK Pixpub for image loading. It has stable links. It allows cross-linking of symbols using JavaScript. So you can tweak the cross-linking for the remote and the local case. And it makes it easier to fix the documentation, because every single type and every single symbol has a link to the source code that defines it. So you can literally jump into the GitLab web UI and then edit the documentation straight from the web browser. It also has client-side searches on an index that is generated at build time as well. So you never send your queries to, I don't know, Google or whatever else. On top of that, we also revamped the GTK, well, I say we, I revamped the GTK documentation website, the GNOME developer documentation there. It's been rebuilt from scratch. We moved from Python to Django kind of ad hoc application that literally took HTML out of the release tarballs, and instead we switched to Sphinx, which is a Python documentation generator. This lets us do things like cross-linking automatically, searches, and everything else. It's also a lot easier to build the documentation locally and test it before sending it to GitLab for a merge request. And then we use GitLab, the GitLab CI pipeline to generate the entire documentation and website and publishing it. So it's a lot easier to contribute there as well. And outside of the content of the developer documentation, we also added new, from the old set of tutorials that were kind of out of date most of the time. We added more content there, and we also adding beginner's tutorials to go from the human interface guidelines to the API references. And speaking of interface guidelines, the same website hosts them, and they are generated using the same tool. So what happened in this last year from December 2020 to now? We work on stabilization. The main goal of GTK now becomes bug fixing and handling feedback from application developers that are currently porting their applications to GTK4 from GTK3, or even from GTK2. But also we want to ensure that GTK4 can be used by various environments and platforms, so it's possible to easily port applications between them. We have aggressively simplified and improved our build system thanks to Meson, and it's possible to go from cloning just the GTK repository to a full build, including the library dependencies, on both macOS and Windows, and we test that on our CI pipeline. There are still some issues here and there, especially some core dependencies on macOS, but we are much more confident about the state of the toolkit there. The CI pipeline for Windows also, we have two pipelines for Windows, one using MSys2, so using GCC toolchain, and then we have a Microsoft Visual C native toolchain. And then we generate the DLLs as build artifacts, so people can literally download them from for a merge request to test if the fix was correct, without having to rebuild the library locally. But another thing that we kind of worked on is trying to make it easier to write platform libraries. Since GTK is used by multiple environments as a foundational toolkit, we wanted to make it more environment agnostic. Elementary XFC are based on GTK, and they provide their own platform libraries for writing integrated applications. By making GTK less beholden to GNOME design patterns, those libraries can now avoid undoing some of the toolkit internal state, or write completely custom widgets to replace GTK's own. And since GNOME is still based on GTK, and it needs a way to implement its own UI design patterns for their own, for its own applications, we worked on a library called Libadwaita, which implements the GNOME interface guideline patterns and widgets. It will also follow the GNOME schedule, essentially, so it will cycle through API a little bit faster than GTK, but also theme changes and things like that. Not every 6 months, but it has definitely a shorter lifetime. Libadwaita was recently released. Libadwaita 1.0 was recently released alongside GTK 4.6 and will be available with GNOME 42 when GNOME 42 is released in March. So I have a few resources here. This is the GTK documentation website and the new developer.gnome.org for the developers documentation. This is the API reference for Libadwaita. As you can see, most of these APIs are generated on GitLab using the CI pipeline, so they're always up to date. The GeoBJ introspection documentation and the documentation for the documentation generator using GeoBJ introspection. And also we have the GTK development blog, where we try to explain some of the internals of the toolkit and outline changes in the toolkit that are coming or that are planned. And we also have a discourse instance, so you can talk to us without having to open random bugs on GitLab and then filling up the issue tracker. You can follow me on Twitter and on Twitch. On Twitch, I do regular streaming where I either write documentation, like the beginner's tutorials for the GNOME developer documentation, or I work on GTK. So I guess it's time for me to thank you And thanks the LCA organization for having me again to talk to you about GTK. And I guess if you have any questions, now would be the time.
Thank you, Emmanuele. That was like a really interesting behind the scenes look into GTK and what's been going on. And I appreciated the history lesson as well. Like, I mean, I obviously, I just had a pronunciation discussion in the chat, so I'm going to say both gnome and gnome myself a fair bit, but I've never really thought too much about how it works. Sorry, the cat is just having a bit of a scratch behind me there. Oh. So yeah, that was really eye-opening for me. Thank you. So we've got a few questions. Let's start with, what are your top bits of advice for people building and maintaining other libraries and APIs based on what you've learned with GTK?
This is a very complex question.
Yeah.
The main thing I'd say is not trying to please everyone. Try to limit yourself. Give you constraint. Writing API is almost like painting or doing any other form of art more than technology. The trick is either in the negative space or in the limits that you set to yourself. The important thing, I think, is to allow people to do complicated things, but not try to second guess where they will go. And there's always time to add convenience API at some point. The other thing that is incredibly important, and I think is fundamental to everything else, is documentation. Documentation. Always write more documentation than you will actually need. I think those are the two main lessons that I learned.
Yeah, I mean, from my own experience, I agree, and I really like the way you phrased that. Yeah, I could definitely hear the years of experience and thinking about those issues behind there. Okay, next question. So you're trying to move away from Xlib. Does that make it easier for the Windows port?
Yes, the Windows backend in GTK4 is incredibly simpler than it used to be. We have more people contributing to it for that reason. We have more people filing issues and helping out because we reduced the internal surface and the concepts are a lot easier to deal with. The Wayland backend is also a lot easier to deal with because I have to implement weird X11 isms here and there. The main thing that changed, for instance, is the clipboard and the copy and paste API. And that went from being a weird protocol based on top of Xlib, the XDND and the selection stuff, to being passing file descriptors around. That was that allows us to make the API a lot simpler as well for application developers. People routinely now come to the Matrix channel saying, I replaced the entire clipboard handling that I had in my application with like 3 lines of code. It cannot possibly be this simple. And we're like, no, it is. It is this simple. It works.
Oh, that's wonderful. That's a joy to imagine. It must make you really happy to see people say that.
Yeah, it does.
Okay, next question is, CSS support was a bold move. Do you think it'll keep up or meet the browsers ever?
We kind of follow the CSS specifications as much as it makes sense for a desktop toolkit. So whenever in doubt on how to implement the CSS feature, we follow the W3C specs. But the GTK CSS is not a web CSS. You cannot influence layout, for instance, using GTK CSS because we cannot allow people to turn every single application into the CSS Zen Garden demo. It would be terrible for documentation purposes, or for accessibility, or for general like reliability. It would be pretty bad. But to be fair, the CSS implementation gave us enough freedom to do a lot more interesting user interfaces than the plain blocky style of UIs. I don't know, we will probably never catch up to the web in the sense that it doesn't always make sense to follow that.
The next question is really interesting to see your revamped documentation workflow. Any specific tips or lessons learned for other projects to ensure docs are both easy to use and to contribute to?
Treat documentation as you treat your code. If you make it super easy to contribute code to your project, you should make it equally easy to contribute documentation. So if you're generating code from your source code, if you're generating documentation for your source code, link the place where that happens from the documentation itself. You can look at how Rust does their documentation, and I mean, I took liberal inspiration from RustDoc and from Cargo for the GTK documentation website. Definitely follow that. Again, if you make it easy to contribute to your code, there is no reason whatsoever you shouldn't make it easier to contribute documentation that way. So follow the same practices there. Allow people to easily open a merge request with the documentation fixes, especially if you can do that without leaving the web browser, for instance.
Thanks for that. Okay, we have time for one more question. How well does GNOME/GNOME 4 work over a network? For example, SSH-X.
Well, if you're using X11, it works exactly the same. If you're using Wayland, then we actually do remoting using RDP/VNC. We have an entire new layer that does that inside GNOME shell that lets you do screen sharing. So basically, you send complete frames, and then you have protocols that do. You can either have dumb protocols that literally take the output and just send it over the wire, with or without compression. Otherwise, you have smarter protocols that can do diffing, so what you send is smaller than that. But in general, the X11 approach is actually the least efficient possible way to do things, because nobody uses X11 draw commands anymore, unless you're using application from the 80s or early 90s. And the other thing is that it's very bandwidth inefficient. It sends a lot of data anyway, interleaved with commands. So if you're using protocols like VNC or RDP, it's usually much more efficient because they can do compression. Or even you don't even need to do that. GTK has a HTML backend that literally runs your application on the server, and then sends the structure of the UI and various assets to using a WebSocket from a server to the web browser pointed at a specific URL and port. It literally works as a remoting API, and I know of people using it in production, which scares the hell out of me. But it has that functionality as well, and people use it. So it's not just, that is definitely more efficient than using X via SSH.
Great. Well, thank you. There was one more question, but we're out of time. So we will transfer that question over to the post-talk chat Kaya Theater channel in Venulus, for you to have a bit of a chat with Emmanuele after the talk, if that's all right with you.
Absolutely.
Great. So thank you very much, Emmanuele, for that really interesting talk. And yeah, your approach to all of this redesign work and so on is quite nice to hear about.
Thank you.
Before we close off the stream for the day, so this is the end of our normal talks for today for linux.conf.au. But there is one more. So if you are a professional or contributor ticket holder, remember to join us from 6:30 conference time in Venulus. It'll be in a different stage to what we're looking at right now for the professional delegates networking session, and a really interesting presentation from Anthony Green on election analysis. So if you are such a ticket holder or a speaker and you are going to that, don't miss it. It's tonight. And for those who are going to that and those who aren't, have a lovely evening, and we'll see you back here tomorrow. Bye.
Bye.